Hello, I am very glad to see you on our section, Knowledge-Oriented Systems. And now I remind that you have only 5 minutes for your presentation or brief description of your research and 2 or 3 minutes for questions. Our first speaker, Ignat Blazhko, and Tetiana Kovaliuk, Nataliya Kobets, and Tamara Tielysheva, the multi-pattern matching with online user requests for determining browser capabilities. You can start.
Maybe our speakers.
Включите нам демонстрацию экрана.
I turned. You have. You can share your screen.
Yes, thank you very much. Dear participants of the conference, I present to your attention the report on the topic the multi-pattern matching with online user requests for determining browser capabilities by Ignat Blazhko, Tetiana Kovaliuk, Nataliya Kobets, and Tamara Tielysheva. The relevance of this topic is determined by such reasons. Nowadays, many companies and businesses that operate on the internet need to have all possible information about users. One of the most effective ways to get this information is to analyze user agent request HTTP header, because this header contains information about the user browser, the platform that the browser uses, the list of browser capabilities, and more. The user agent database contains over 62 million user agent strings. The library Blazhko data contains 200,000 search patterns for analysis of user agent strings. Quick methods of analyzing this pattern are needed. Example of user agent string search pattern for its analysis and user agent information you see in this slide. The purpose of the search is to develop an algorithm for multi-pattern matching with wildcards to be able to detect browser capabilities based on the library Blazhko data. The library should work faster than its alternative. The speed should be comparable to libraries that use simplify or inaccurate method to detect browser capabilities. To achieve this purpose, it is necessary to solve the following tasks, which are shown on the slide. The task of determining the browser capabilities based on the analysis of the user agent HTTP header is reduced to the task of matching text string, which are used as search patterns and incoming requests. The formal statement of the problem is as follows. Suppose that is a set of search patterns that are entered into the search engine. Each search pattern is a string of characters that belong to some alphabet. Each pattern contains characters which are called wildcards. The search pattern can be represented as a string with wildcards character and keywords from a dictionary of unique words. Input requests are a string consisting of some characters in the given alphabet. It is necessary for each input string to find all the search patterns from the set of patterns that match into this query string. The number of requests is not limited. Requests must be answered as they are received. To solve the problem of matching an arbitrary number of search patterns with instance of text, an algorithm based on the prefix tree as a data structure, and the finite automaton based on the modifier Hierarchic algorithm is proposed. The prefix tree is built based on input patterns, An automaton built according to the Hierarchic algorithm is used to quickly search for keywords in the text of incoming requests. Terminal links are added to the automaton to speed up the search for keywords that are prefixed to other keywords. When a new input string is received, it is counted and a set of prefixes of possible search patterns is constructed. At the beginning of the Hierarchic algorithm, finite automaton is constructed based on string from the dictionary. This automaton is a prefix tree with additional suffix links. The behavior of the automaton can be described by the transition, failure, and output function. The algorithm consists of two parts, pre-processing search patterns and online part of the algorithm. On the pre-processing search pattern stage, we construct this set of all unique keywords. Then we obtain the bijective reflection, the keywords to any symbols and other. We build the set of converted search patterns by replacing keywords in the pattern with character of the given alphabet.
Sorry, Tetiana, you have only 5 minutes. All participants of this conference have time for read your publication and watch your video on YouTube channel. So you need to present only main idea.
I finish it. I will finish it.
Okay.
In the slide, we see a prefix tree based on the set of converted search pattern. In the slide, we demonstrate the transformed prefix tree. Our result is presented by software component structure of this program we see in the slide, and the result of analysis of user agent by development program we see this. Our result with analysis of benchmark and result shows that our algorithm is difference on 7 times with other. In conclusion, an algorithm for matching an arbitrary number of such patterns with text instance in real time has been developed. The time complexity of the algorithm and memory consumption were analyzed. The software implementation has shown a significant performance advantage of the existing technology for identifying browsers capability. And further research can be done to optimize memory consumption during the operation of the algorithm. Thank you for your attention.
Thank you. Do you have questions?
I have some question maybe. It's not clear for me about performance indicators of algorithm which were given and about assessment of efficiency. Або я можу, або українською я можу ще повторити своє запитання, що в мене запитання стосовно показників швидкодії алгоритмів та стосовно числового дослідження цих показників та оцінка ефективності програмного продукту. Дякую.
This slide demonstrates the efficiency of our algorithm. The library name is shown in first column, and our algorithm, the speed of our algorithm, the speed of work our algorithm is shown in this column, in this chart, and we see that our characters is speed of work union in millisecond second 40, and other algorithm and other tools demonstrate slow, low speed and accuracy algorithm. This is precise method, and our algorithm is demonstrate very low accuracy, during the benchmarking testing of the developed library, the efficiency of our work and significant advantage of speed compared to the difference of 7 times advantage our algorithm. And estimation of complexity algorithm was presented on the slide. Our estimation
Okay, Tetiana, thank you very much. Thank you. I think you present full answer on the questions on the questions. The next presentation, construction features of the industrial environmental control system. Welcome.
Good day, dear colleagues. First of all, sorry for my bad English. Full presentation is available on YouTube channel. And now let me introduce you a short version of my keynote. The topic of my report is construction features. Sorry, let me share your screen. I forgot. Yes, now you can see. The topic of my report is construction features of the industrial environment control system. Authors Andrii Vasyliuk and Basyuk. Maybe go now to the next slide. Scada is an architectural scheme of industrial control systems with many components that are often distributed over a wide area. Is a critical information system. It critically stands for the fact that SCADA systems are vital components of the critical infrastructure in most countries. The control pipelines, water supply and transportation systems, utilities, refineries, chemical plants, and a wide range of production operations. The market of SCADA system nowadays is quite large. They all have different capabilities in terms of convenience, cost, and speed of development. Today, the main problem is the creation of large projects with many elements in the diagrams of the need to calculate large amounts of data, which significantly affects the speed of the system. One of the important factors is the high cost, because when developing a large industrial solution, the cost of the one copy of the object can be hundreds of euros. Unfortunately, open source systems do not solve this situation, as the union of the stakeholders is limited in number. Next. Having solved all about problems, the ideal SCADA system must meet the following requirements, which you can see on the slide. So speed of work, flexibility, data structure, complexity, and other. Win CCUA SCADA system has advanced user interface tools such as graphical element ladders that meet modern trends in HMI tools for visualizing data flows, identifications, advanced properties editors, tools management of saved data panels, and also provides the ability to support visual programming, creating user interface for devices based on iOS and Android. At the same time, the various tools for WinCCUA, which provide ample opportunities in the system engineering, require the developer of higher engineering education and responsible choice of design solutions that ensure reliable operation of the system at all stages of the life cycle, significantly increasing the cost of the system and complicates the development processes. The complexity of this system doesn't justify the amount of functionality it provides, but only slows down the process of the staff training and integration of new components. Let's see poster 6. Next poster. Another perspective in the market in the market of SCADA system is web access. With the help of this SCADA, it's possible to build an automated control system for industrial processes, as well as to remotely configure and maintain the created system during operation. The use of HTML5 provides appropriate opportunities, but also imposes certain limitations, namely the speed of graphic signals processing and their timely display to the operator, which is critical in the construction of large-scale industrial system. Another problem with web access is problems with the integration of third-party services and databases, which lead to frequent errors and problems with access to the system. For modern SCADA systems, such processes are unique table as they entail high costs or stop the industrial processes. In the situation on the market of SCADA system, the main problems encountered in the products are analyzed and characteristics with the modern SCADA system are derived. An object-oriented approach was chosen for the design of the industrial environment system, which includes the construction of UML diagrams. Class diagram is one of the most important type of UML diagrams, which should reflect the logical structure of the simulated system and the basis at the beginning of the system development. Classes and the relationships between them are part of this type of diagram. Based on object-oriented programming templates, the class diagram represents the structure of the model, describes the different types of relationships between objects, gives a clear description of the internal structure of all objects and subsystem. The sequence diagram shows 5 objects: administrator, engineer, template model, report model, and database, between which there is a transmission of messages presented in the form of requests and responses. Package diagram are diagrams that shows the dependencies and relationships between packages. The system of an industrial enterprise must solve the following tasks. First task is the creation of a data warehouse in ability to write data to external media. Next is the development of an information panel that will provide the engineer with timely real-time information about the state of the enterprise. And last one is the development of the identification model that shows signal conflicts in the system in real time. Templates are elements in the application server that contains common configuration settings for the instances of objects that are used multiple times in the application. One of the main advantages of the system platform is the ability to centrally develop, manage, update, scale, and maintain all automation systems for management, data processing, and visualization within a single clear, integrated, and powerful environment. The main task of the Wonderware system platform is to build a system in the enterprise with accessed information in real time. The hardware system is built on the basis of Arduino Uno as a microcontroller for processing signals from the sensor. Each of the 14 digital ports available in the Arduino Uno can be used as an input-output using the pin mode. Next slide, we can see. The next component of the hardware is a soil moisture sensor. This sensor is designed to collect water level data. It has built-in potentiometer to adjust the sensitivity of digital output D0, which is not used in our case. A power LED and digital output LED. The sensor consists of a probe through which it receives information above the water level in the tank. The main task of the system is to provide information in real time in a convenient and pre-selected form to users. To start the build system, you need to run it in an appropriate environment. To get started, the user must log in into the system with the appropriate login and password to gain control over the required functions. After confirming his identity, the user gets to the main page, which displays the two sections of the system. First section is industry. It's responsible for the checking the state of industrial systems and process enterprise. This screen shows a simulation of real production processes with the corresponding indicators of the industrial facilities. Next, the system allows the user not only to receive information in real time, but also to work with historical data, generating reports based on them. The system also allows you to download these reports in user-friendly formats. And as a result, conclusion, yes, as a result of this work, an industrial enterprise system was developed. The results of the work performance are as follows. The market of similar software solutions and technologies leading to its analysis. The main problems or market products are shown. The structural processes of system creation are described. Rational unified process was used as methodology and to create the last part of product as the most important focus in the case in the working product. The information system of the industrial enterprise is constructed with the hardware part in the form of the microcontroller and the software part in the form of the information panel. The detailed description of the design system and test examples of its work is resulted. For me, that's all. Maybe you have some questions.
Thank you. Very good presentation. I have a question. So, if I correctly understood, you did all pipeline from development to production, yes?
Yes.
And receive real results on production.
Yes.
Okay, so it's really interesting, and I think it's very useful because a lot of people knows about clever house, yes, but
Yes.
few people knows about industrial environment, yes, because we have a lot of small factories, yes.
Yes.
Which you can use your software. Okay, so maybe something else wants to ask a question.
Sorry.
No, thank you. And the next presentation, development of predictors to increase the efficiency of progressive hierarchical context independent compression of images without losses.
Okay, hello. Let me share my screen.
Yes, no, we can see you without your screen.
Yes, I'm sharing my screen.
Yes, okay.
1 minute. Yes. Can you see it?
Yes.
Great. Okay, dear participants of the conference, I'm willing to present you the report on the topic development of predictors to increase the efficiency of progressive hierarchic context-independent compression of images without losses. So actually, in today's world, images are an integral part of multimedia information, which is often created, stored on digital media, and transmitted through communication channels. Compression of the respective files allows us to increase proportionally the speed of information exchange over the network and reduces the amount of disk space usage. Thus, the development of methods and graphic format for lossless image compression using the principles of progressive hierarchical processing, which is the purpose of the study, is an urgent task today. As it's known, lossless image compression in graphic formats often consists of 3 stages. On our search, we were working on the third stage, context-independent part. Progressive hierarchical compression of images allows to speed up decoding and, on the other hand, to consider the values of previous processed elements from 4, not only just from 2 different sizes in the process of using predictors. That's why, to achieve the goal of the study, we have developed an effective scheme of pixel traversal and appropriate predictors that implement progressive hierarchical compression of images without losses. In particular, for a progressive hierarchical traversal, we presume in which the pixels of the image are processed sequentially on the first layer, starting from the first in rows from top to bottom, and in each row from left to the right, where from left to the right in steps 2 to the kth power, where k is determined from the condition that you can see on the screen. On the next layers, intermediate pixels of the image are processed in the 2 passes. On the first pass, those of them which are contained on crossing of diagonals of squares with vertices in adjacent pixels of the previous layer, with a step 2 to the key plus 2 minus L power. Bottom lines and on the columns are processed. On the second, unprocessed pixels are processed between adjacent pixels of the previous layer on the first pass with the same step on columns and with it twice reduced on lines. On this image, you can see that P is for pixels that are processed on the first layer, 1 is for pixels that are processed on the first pass of the second layer, and 2 is for the rest of them. I'm sorry. On this screen, you can visually see the results of processing the image length in each of the 5 layers. As it's shown, the more pixels are processed, the better image is. All our tests we conducted by the use of the standard set of the images that is used while every algorithm is tested. So actually on the screen, you can visually see all the images. Let me share with you the result of our testing. So here on this table, the line non-predict shows the entropy of the brightness values of the components of the pixels without the usage of predictors. And below, the entropy of the same brightness after using the most common predictors of sequential traversal and symmetric predictors of hierarchical traversal. In the initial passes of the hierarchical pixel traversal, symmetric predictors were not used if they increased entropy. As it was expected, the usage of noise trend predictors 2 and predictor 4 proved to be more effective for synthesized images, as they are characterized by sharp differences in the brightnesses of the processed pixels within the depicted object. Trend noise predictors 1 and 3 were more effective for photorealistic images because they adjacent pixels often have similar but different colors. The use of symmetric predictors significantly reduces the entropy on the last layers compared to other currently known sequential traversal predictors, as these predictors considered the effect of 4 equidistal pixels on different sides, not just left on top pixels on each sequential traversal. In this case, each processed pixel on the next layer in the middle of the image is used to process 8 pixels of the next layer. The noise predictor 1 and 3 provide almost the same compression ratio, but predictor 1 requires fewer operations and comparison operations, so it's chosen as the base. Also, we tested the images set with the use of asymmetric hierarchical predictors. The results of their application are shown in table. From the data in the table, we see that the use of the asymmetric predictor 5 slightly reduces the entropy of images without noise, and the predictor 6 significantly reduces the entropy of the image 1 and compresses the rest of the image worse. Asymmetric predictors are used to predict the values of 6 rather than 4 previously processed elements, and are therefore calculated much longer. Such predictors can be used to provide maximum compression, but they are not suitable for graphic formats where fast decoding is required. So during the research, we came to the following conclusions. In the new versions of graphic formats and new lossless image compressions formats, it's advisable to implement progressive hierarchical compression, as this allows you to speed up decoding significantly when the size of the output area is smaller than the image size. During the context-independent lossless compression for homogeneous image fragments, it's advisable to choose the predictor from several alternatives that allows to minimize the entropy. Thank you for your attention.
Thank you, Veronica.
Okay, maybe you have some questions.
Yes, we have only 2 minutes for the questions for Veronica. So some questions, please.
Sorry, maybe I have one question. What is about scope, maybe scope of this application of your method, of useless of this proposition?
Yes, actually, all these predictors were known before, and our method is like the set of how to use all these predictors one before other. So in scope of this article, we developed the code in C language that helps to reduce images and to compress images and to decrease the entropy. Thank you for your question.
Thank you.
So actually, yes, the output of the article is the method that compresses image better than the methods known before. Thank you.
And what about compression with other methods? Because images and it is very popular now, and there are a lot of methods to recognize.
Sure. We didn't implement already known methods here, so we just added another sphere, not another sphere of compression, but the possible variant of how to make already known compression algorithm better.
Veronica, sorry, because I need to interrupt you because we have few time.